All right, let's take a little bit to talk about slotting. When I say slotting, I don't mean slotting like if you had a equal distance, basically a pocket that acts as a slot, sort of like what would be on a linear cam or stuff like that. That has its own special slotting operation, and that's really not applicable for this. What I mean is undercutting with a slotting cutter. And I think that throws people off their first inclination as they see this slot thing and the icon's not super descriptive for what it's for. I mean, you definitely could confuse these two things because the term's the same. What I mean is for undercutting with an actual slotting cutter, a disc mill, whatever you want to call it, T-slot cutter, key seat cutter, all of those. They're all terms for basically the same thing, which is a cutter with a lot of relief. And so I kind of divide this into two things. There's slots or geometry that's like this, where it's pretty clean. It tends to exist on a 2D plane. You wind up with clean geometry. You can usually do it with a 2D operation. And so this, I would call this a true slot. The geometry might look a whole lot different than this, but they'll all be covered basically the same. The other stuff is just sort of general undercutting, and you'll follow those, or you'll approach those in two different ways, mostly because a 2D, the other general contouring won't have clean geometry, and it'll just be sort of like arbitrary stuff that you want to surface underneath. And in those cases, you'll be cutting purely with sort of the outside edge of the cutter. I have one sort of made here that will, if you're trying to surface, you can surface with the very outside edge here, but you won't probably want to use a whole ton of the depth all at once in those cases. So I have a cutter here that's built up that we'll use for example of these sort of mechanical or clean 2D slots. It's a 3-inch diameter cutter, 1/4 inch tall with a 30 thousandths radius that just happens to match the radius here, and it looked like it should clear everything here. So most of these types of slots you'll probably want to approach with 2D contour or 2D adaptive clearing. Unfortunately, I don't think 3D adaptive really will see any undercuts. It just doesn't support them. But you can use 2D adaptive. You just have to be kind of careful to remove any lifting and sort of make sure that any connecting moves and stuff like that are clear. Let's start with 2D contour. So we'll grab that tool, and we're going to grab the chain that defines the final geometry. I'm going to do it sort of the quick and dirty way first, and then we'll come in and add some detail and refine this. So I chose that chain because of the fillet. It's not really picking the bottom correctly, so we'll choose the bottom. Again, I'm sort of going to do this wrong just for example. We'll pick this as the top because that's sort of the logical thing to do, but we'll cover why that doesn't really work. Obviously our 1/4 inch cutter is not quite going to cover this, so we'll say multiple depths. We'll put in something like 0.18, and that's probably all of the configuration we want to do for now. We'll see what that gets us. So I got us some toolpath. Let's see how it looks. So I'm going to dive first into the top cut. Well, here we'll just go ahead and start up the simulation. So the first thing you're going to notice is that it's going to gouge, and that's because of how we defined the top, and it wasn't right. So what we did is we said we wanted to start cutting at this surface, and we wanted to do it in passes that were 0.18 depth, right? Which drives this point, which is your cutting point, right? The outer bottom of this disc mill, down from this surface by the maximum depth that we set of 0.18. The problem is it has no idea that this material, or that this saw has thickness, or that this material exists. We're just saying it's a 2D operation. Cut this profile, start at this point, and come down in multiple depths by 0.18. So we could get better if we wanted to drive it by if we set our maximum depth was 0.25, then all of our steps would be at 0.25, and what you'd wind up with is this scallop right here times 2 because of the top and the bottom. You'd wind up with that all the way around, and that's not what we want. So what we want to do is we want to figure out the point where we actually want to start, which is going to be lower than this point. It's basically dropping it by this exact amount right here. And then from that point, we want to do 0.18 depths until we reach the very bottom. And so we can do that, but I think stopping and explaining it like that will help when it comes to sort of building an equation. Let's skip, let's show all toolpath. Let's drop down to here. The other thing is this did happen to wind up with enough lead-in, just because sort of the lead-ins are based off of the diameter of the end mill, and they're sort of scaled up, and this section's pretty small. It doesn't have a lot of depth to it, so we did wind up clear on the entry, but there really wasn't. That was just basically luck of the geometry that it did that. What we want to do is figure out a way to force it to be clear right away. And then the second thing you can see is that this right here, if you watch that as it comes in, I mean, this is just way too much engagement. There's just no way that in anything but maybe the softest of plastics that you're going to be able to drive a saw like that, which is sort of inherently not rigid because it's huge diameter with small arbor, into that much material. And I think even in the softest of materials, you still probably wouldn't really want to do it because it's just generating a huge fluffy chip. So what we want to do is probably clean up and add some more passes in the areas that we want more passes. Other than that, it looks pretty good. I think in an ideal world, you'd want these to be equal steps, and you can tweak that by getting the maximum to be closer and get something that's close. But what you won't want to do is use even step downs, at least with my method, because it'll, well, I'll show you in a second. Okay, so the first thing that you know in order to, let's start by, let's correct one issue at a time. Let's correct the depth issue first. I think what you need to realize, or hopefully you're aware of already, is that everything in HSMWorks, every field is available to you as to feed another field as a variable. You can see these a lot, and so you can use those fields to derive an expression. You can see these a lot if the defaults of a whole bunch of stuff is just sort of set at it's pointing the field to another field, if that makes sense. So like this, we can augment our finish feed rate, but the default is that it's just pointing over here to the cutting feed rate. And how do you know that? I just edit expression, it shows tool feed cutting, and then when we come over here, if you hold down your shift key and hover over cutting feed rate, you can see at the bottom there, it shows parameter name, tool underscore feed cutting. That's the parameter name for this field right here. And like I said, every field I believe has one. I haven't noticed any exceptions. So what we're gonna do, and I can't take the credit for this, somebody else, I think in the first week that I was using HSMWorks, I actually had an application that I needed to use this for, and they just said, hey, try this equation, this should work great, and it has, and I've used it 1,000 times now. Okay, so what did we talk about? We said we want to start at this point and cut down, but we have that extra bit of material. So it's basically the difference between where we start, the width of our cutter, or the height of our cutter, and the maximum that we're allowing it to step down, right? So if we were to take and hop into our library, edit the tool, and let's look at the cutter, and let's look at the flute length, because that's what we care about, right? So it has tool underscore flute length, and keep in mind that everything, whenever you're using these, it is case sensitive, and they follow sort of an odd case sensitivity, in that you get used to it, but it's almost always if there's multiple words strung together, then the later ones will all be capitalized, first letter. So anyway, tool flute length, so we're gonna wanna remember that one. Okay, we'll keep that one. And then multiple depths, so here we have maximum step down. So let's take and drive this. We still wanna use that selection, which we have selected, but we want to augment it. And so we want to say, we want to go from our top, we want to go minus the tool flute length minus the maximum step down, parentheses. And you have to be clean about how your equation functions and follow whatever those parms or whatever math rules. So then we get an equation is putting out minus 0.07. And we'll check that and see if it works. It should. Let's generate now and see what we get. Okay, so coincidentally, that cleaned up our number of passes, which is cool, but totally just luck of the draw. Let's come down and look, and perfection, it nailed it perfectly. And obviously it didn't change where it's ending. That's still ending perfectly as well. So that one's nailed. Okay, so let's see what else. I think this next one we can kill two birds with one stone. We can jump in here. We can look at, we wanted to make more passes, right? We only have one pass coming around and we just don't want that engagement there. So what we want to do is also tell it where the stock is at, and then also enable either multiple finishing passes or roughing passes. I think we'll use roughing passes. So you can see there I enabled stock contours, and then I know that I had already finished the outside of this. So the place where the stock exists is the orange. So we're going to say we want to cut from the orange to the blue, right? Orange everywhere within where orange is at exists, we want to cut up to the blue. Hopefully that's straightforward. So then when you come in here and enable roughing passes, and we can say we want to give it 6 roughing passes, and we only want to take a step over of 1/8 of an inch. And I'm getting a warning there. Oh, purely because this is driven by an equation. Actually, we'll just say 50 thousandths. That should give us an extra pass everywhere. So I told it 6 passes. I'm thinking maybe that's enough, whatever. All it needs to do is you have to figure that it's going to take this, when you enable roughing passes, what it's going to do is it's going to first generate a finishing pass, and that will be on the blue. It'll be bringing your cutter all the way to the blue. Then it's going to offset by this amount, and then generate your first roughing pass there, and then it's going to continue generating offset passes, just literally increasing, just like if you made a sketch and did offset geometry. It's just going to offset that geometry out. And then once the blue crosses over the orange, it's going to start trimming those up. If that makes sense. And then it will hopefully connect them nice and cleanly. Let's take a look. Okay, so we got a ton of passes there, but I kind of forced it to do that because I said, let's offset by 1/8 of an inch or whatever I said. Let's take a look. So you can see that these leads are now nice and short. It's sort of trimming those up to try and keep us closer in contact. You now see that this is it's much more efficient. This is probably overkill on the number of passes now, but you can tell that it's doing a much better job of removing that material gradually. In fact, let's just go ahead and jump in here and we'll do a stock simulation. Remove the top, remove that, then we'll slow it down. Slow it down real good. Right, so it still isn't gouging because now it knows where the stock is, and it can literally just use our keep away parameter and drive it as close as it needs to there. And it's just running those offset passes. It's doing it pretty clean. On a toolpath that's like this, where it's all sort of OD and open, there's no ID curves, 2D contour is going to work perfect. It's never going to really drive the saw into an ID or a high engagement area. Everything will just be pretty accurate or even lower engagement than what you're assuming with the offset passes. Hopefully all that makes sense. I'm sort of assuming that you're a machinist and know what you're doing on that level. But yeah, this will be nice and clean. If that's not the case, or if this just isn't generating a super space efficient toolpath because of how the geometry looks, 2D adaptive can really be a good way to go as well. It just takes a little bit more tweaking to get it safe. But yeah, like this, because it knows where the stock is at, because it knows where you're cutting to, it's always basically going to extend the lead outs to know that it's dropping in a safe place. The way that I did it the first time, where I hadn't selected that stock contour, that doesn't really know where the stock exists. It has no idea. You haven't told it. It just assumes that there is no stock and we're just going to drive the cutter there. But this is a really dangerous situation where there definitely is the possibility for a collision. So it's always good to define that stock. Plus, it just makes your life easier if you need to add offset passes. I think that's pretty straightforward, and I think we covered it pretty well. Let me know if there's any more questions or anything if I skipped over something. I'm probably just going to put this one up without taking too much of a look at it. Yeah, I think that's it. All right, of course, I immediately came up with a couple more things that I had intended to show and didn't. One was I wanted to force this collision. So I added an entry point here. Let's go ahead and grab this entry position. Let's grab that. Should now start from there. Yeah, okay. So this probably still isn't colliding because the reach just is too much. Yeah, so we're still clear there. But let's force the collision. Let's fix the collision, and then I want to show a little bit of a glitch that you should be aware of and that probably should get fixed. Okay, so now this is going to have a collision, right? So this would be plunging down through. That would be bad, right? Okay, so we can fix it. Well, I'll show that the stock contours mostly will fix it. And you can see obviously here I've removed all of my extra passes and some stuff like that. Okay, so that fixed it on the lead in, right? You can see there that it now came down and is way clearer. But let's look at this. You can see pretty quickly it added some linking in here and it didn't add it in there. Or it added some lead in there and didn't add any on the backside. And so here on the lead out, still got a crash. So that's not great, right? And I think that the reason that it's doing that is that they're assuming that the software is assuming that all of the material from that contact point up has been removed. And so they're trimming this down. And that's sort of a fallacy here. And it definitely causes a pretty dangerous situation. So keep an eye out for that. I've never actually had it be an issue, but I've seen it before. Let's see, what else? Okay, I had mentioned that you can't use use even step downs. This is usually a tool that I love to use, but it just really won't work here if you're using this equation to drive it or to drive the top depth. It's just not going to work, and the reason is that basically what use even step downs does is it still keeps the maximum, but it really turns the maximum into a maximum, if that makes sense. And then it is sort of correcting the actual depths that it's using afterwards. And the problem is that this can alter the first depth to be less than what the maximum is, and so then you'll still wind up with a gouge, and it's just not going to work, if that makes sense. Basically, if it needs to add in an additional pass, or if it needs to spread out the passes to be equal, which is the function of what this does, it basically pushes the first pass up by some amount to make it even with the others, and then the equation's wrong. And there's just no way, because that sort of happens after or during the toolpath calculation. It sort of does that evening out almost as sort of a last step. There's just no way for us to pull that the actual step down back into our top equation and correct for it. So that just isn't going to work. The last thing that I could think of, I wanted to show that the cool thing about using an equation like this, you can see right now it's at minus 0.07, but it didn't just use that equation once, or that expression once. It's still in here. And so that means that it's still going to be parametric. So if you go out to the shop floor or whatever and you realize that you really only have a 5/16 saw, and you hit OK and you select it, when you come back in here, that has already, because it's reading that length, the tool flute length, it's already updated. And similarly, if you realize then, well, geez, I have a bigger saw, I can take more depth than that, it's already updated. And, say you really wanted to be optimal with this depth, you can take and even go, let's see, tool flute length minus the tool radius, or tool corner radius times 2, and then we'll just go all of this times 0.8. And we'll see if that evaluates right. So, you know, in that situation, what we did is we took the whole flute length, we subtracted the 2 radiuses because we have one at the top and the bottom, and then we say we want to take 80% of the flat, and that gets us a nice clean number there, and we'll see how this actually works out. We managed to get 3 pretty clean, don't want to post process. 3 pretty clean passes there randomly again, and then we'll go ahead and run the sucker, and I think I left the gouge in there. Yep, and you'll see it there. So let's ignore that. And you know what? That didn't work out as nicely as I expected. I thought that was going to work better. But, oh well. Tried to be too fancy. Life goes on. Okay. I'm calling that good. It's getting pretty late. Hopefully we'll start seeing more videos from me. I just brought a Swiss lathe that's sitting down in my garage. It's just freezing cold out there, so I wasn't excited to go down and do any work tonight. But I'm going to start trying to stick a video camera down there and show people what's going on. Yep, that's it. Take it easy. Subscribe, do all that fun stuff.